Jim Fletchner already had one of the toughest jobs in town, even before Gen X was discovered in our water. He's the executive director of Cape Fear Public Utility Authority, which provides water services to 200,000 people in New Hanover County. Today, Jim is going to talk about the approach CFPUA is taking to deliver clean water to our community. Please join me in welcoming Jim to the stage to talk about One Water.
Good morning. When we think of water, it's easy to put a label on it. Groundwater, drinking water, wastewater, sparkling water, and the list goes on. But when we label water, it becomes just a little bit too easy to distance ourselves from that water. That's a groundwater problem. That's a wastewater problem up in Greensboro. But in the end, there is only one water. And we, in this community and in the state, use that water over and over and over. We don't take it, we borrow it. And last time I looked, no one's making any new water. So it's important for us to treat this water properly, to treat it with respect and make sure we're protecting it. The way we take care of water is our common interest and without doubt our shared fate. So whose job is it then to regulate water? Well, it starts at the national level at the US EPA. They have the scientists, the toxicologists, the researchers, the regulatory authority to understand what contaminants are out there and what they might mean for public health and drinking water. And that's what we're talking about here is public health. So EPA sets standards nationally for drinking water across the country, and that makes sense. So we have a reasonable expectation as we travel around the country that wherever we go, the water that we drink is going to meet certain standards and it will be healthy for us to drink. Here in North Carolina, NCDEQ, Department of Environmental Quality, then takes those national standards that are set by EPA and regulates all the individual utilities such as CFPUA. They enforce the drinking water standards, and they're also in this unique position to also regulate what is discharged to the environment. Not just what do we do with the water, but what is discharged to the river, what's discharged to the air and the groundwater. So they know who is upstream of us, they know who is downstream of all of the people who discharge to the river, and what those uses are. And it's part of their job to then resolve that and make sure that no one upstream is affecting somebody negatively downstream. Our role here as a utility is pretty simple. We follow the rules set by DEQ and EPA. We take water from the river and the ground, we clean it, and we send it out to you. And when you're done with it, we take it back, we clean it again, and we put it back in the river. And that's what we do. It's a couple hundred yards from here is where we discharge it. So we just borrow the water for a couple of days here. And that's that one water. It becomes our drinking water for a while, it becomes our wastewater, and then it's back in the river for recreation, navigation, and all the people who are downstream of us who use the water. We've all heard discussion about emerging contaminants, all these things that are out there. And to give you a sense of scale, there are about 85,000 chemicals in a federal registry. Fewer than 10,000 of them actually have any health studies or information associated with them. Not saying there are 10,000 chemicals in our water, just giving you a sense of scale that there's more that we don't know than we do know about a lot of these chemicals. And the problem comes in when the health regulations and the science can't keep up with all of the new products that industry is producing. And we love that. We love our phones, we love our Gore-Tex, we love our stain-resistant carpet, stain-resistant furniture, and all these things that make our lives easier. But the problem comes in when some of those products make their way into the environment, and in our case, into the river, and into the water, which then becomes our drinking water. And what we've been talking about, and it's dominated our public dialogue for the last year and a half or so, are these PFAS compounds, these polyfluorinated substances, and Gen X is just one type of a PFAS. And by no means are we suggesting that every chemical is bad. We use chemicals in water treatment. We put chemicals in there to get the water clean, to keep it clean, and make sure it's safe to drink. So no one is suggesting that all chemicals should be shouldn't be in water. We need them there for good reason. So what do we know about these PFAS? Well, we know they're in the Cape Fear River. And the problem comes into, and that very little is known about these PFAS compounds. Some of them have been around for a long time. They come from Teflon and all these other uses, but there aren't many health studies on them. And the health studies that are there suggest that you don't want to be consuming this PFAS. It's unhealthy for you. And what we know very little about is when you have multiple PFAS stacked up, what are the health implications then? What is the additive effect of drinking multiple PFAS in your water? But one thing the experts do know is that reducing exposure to PFAS is a good thing. It's protective of public health, and that's what we're working toward at Public Utility Authority, is reducing exposure to PFAS. Only about 1/5 of your exposure comes from your drinking water. The rest comes from cooking, clothing, and all the other means that we're exposed to it. Packaging and for food has PFAS in it in many cases, but we can focus on our end on that 20% and reducing your exposure. And one of the ways we do that, of course, is to understand what's out there. We monitor for 45 different PFAS. 8 of those PFAS are so new and so obscure there aren't even testing standards for them. We can detect them, we know they're there, but we can't determine what level they are. And that's like knowing that there's gas in the tank of your car, but without a gauge, you don't know how much. You know you have fuel, you just don't know how much, and that's the case with these PFAS. It's there, but we don't know what the levels are. We regularly detect 10 PFAS in our water, and we're working with the scientists at UNC Wilmington, the chemistry department, to answer the question, what else is out there? We heard about Gen X a year and a half ago. What other compounds do we need to be thinking about? And it seems like every time they look, they find another one. And they found an additional 5 PFAS compounds that hadn't been reported previously. So as a utility, what do we do about this? We have no regulatory authority to tell ChemOrs or anyone else what they can or can't discharge to the river. So we began researching what steps we can take at our water plant to reduce levels of PFAS. Again, the lower the exposure, the better from a health perspective. So we worked with our consultants and found that we can use granular activated carbon, or GAC, to reduce PFAS in our drinking water. And that's a good thing. Our Sweeney plant, which is just north of here on the river, is in the top 2 or 3 in the state in terms of its ability to treat water and clean it and make it suitable for people to consume. But it was never designed to filter PFAS. And that gets back to those roles. It's EPA's role to set those standards, and they have not addressed at the federal level what is an acceptable concentration of PFAS in water. So our plant was never designed to treat for it. But we're working on that. Given what we know about PFAS, what's happening upstream, the levels we're detecting, we are in the process of designing an upgrade to our plant. That will take us about 3 years to complete. The benefits of designing a new treatment process, first and foremost, we continue to make good use of the investments in the plant. We already have advanced treatment there. It's one of the best plants around. By adding GAC to it, granular activated carbon, we'll continue to provide the best water we can. And we'll be able to reduce levels of PFAS in our drinking water. So how do we do all this? Well, everything takes money, right? And we have spent about $2.5 million to date on legal fees, testing, remediation, studies, all to address Gen X and the other PFAS. We shouldn't have to be doing that. In fact, our roles have blurred significantly when we're doing research. That's an EPA and a DEQ function. But that wasn't happening, so we had to step forward and do it at the local level. It'll cost about $46 million to upgrade our plant, and that's a lot of money. I'm sure if we had an extra $46 million around in our community, we could build a county park, a school, expand the airport, a lot of things we could do collectively with $46 million besides adding treatment to our plant for something that somebody else is putting in the river. And it'll cost about $2.9 million just to operate that additional treatment process once it's up and running. What this all translates to then is about $5 a month for a residential customer in extra cost. We have about 67,000 accounts, so that's a lot of money that's coming out of our community and being spent on water treatment that could be used somewhere else. It seems to me that the people who pollute the environment are the ones that should be paying for the treatment. So we are taking legal action against Chemours and DuPont to recover these costs. We're still looking at a 3-year timeline until the plant expansion is complete. So what do we do in the meantime? Well, our plant wasn't designed to filter these compounds, but we did come up with a way that we can force it to do something that it was never intended to do. And we can swap out some of our existing filters with GAC and get about a 40% reduction in the levels of these compounds. That's an interim step. This won't work over the long term. And when I say swap out filters, I'm talking filters as big as this footprint of this stage with GAC about 4 foot thick in it. So it's no small thing. This isn't the Brita filter sitting on your home counter. How do we navigate all this? How do we sort through these complex problems here locally, and how do we work with people? Well, we've been working very closely with the General Assembly, and they have helped to offset some of our expenses, and we're very grateful for that. The fact is the regulatory framework of EPA, DEQ, and then the local utilities is not sufficient. Otherwise, I wouldn't be having this discussion. Somehow we ended up with these PFAS compounds in the environment that have serious health implications, and there's not a drinking water standard for it. That's just a fact. Source control is the best answer. The expense should be at the source where people are generating these contaminants before they get to the environment, whether it's in the air, the groundwater, or whether it's in the river. But the fact is the groundwater is already significantly contaminated around the Chemours site, and all indications are that the sediment in the river is contaminated, so we expect to see these compounds to continue for some time. Even if they stop discharging, we've got to deal with it downstream. We continue to find contaminants. The UNCW 5 compounds that they found are out there. We don't know how many more are out there. We know reducing exposure is protective of public health, and that's our mission at CFPUA, is to protect public health, and we do that by doing all we can on the treatment side to make sure our water is as clean and as healthy as it can be. And there are solutions. We can use GAC at our plant to reduce these levels. But remember, there's just one water. Just like Chemours takes water out of the river and it runs it through their plant, and they do what they do with it and they put it back in the river, unfortunately as contaminants. We do the same thing here. We take it out of the river and out of the ground, we all use it and we put it back in the river. So we all need to be collectively mindful of what does that mean? How does that affect people downstream? And what does that mean to the environment and public health? There is only one water. So while this presentation is just about over, our work at CFPUA is nowhere near done. You can stay up to speed with this by going to our website and signing up for a news flash, and we'll send you information as we get it. There's information on emerging contaminants, water quality, chemistry, everything you ever wanted to know about water treatment is there for you to see. Thank you very much.